Hello everyone. In previous two classes, we have discussed about dual of a problem and some problem related to dual, right? Now let us discuss duality by using the simplex method, right? That is dual simplex algorithm. First we will discuss about the basics of this dual simplex algorithm. Okay? Now, first step is convert the problem to maximization form if it is initially in the minimization form. Okay, suppose if they given the problem under minimization, we need to convert it into the maximization. Okay, now convert greater than or equal to type constraint if any, then we have to convert it into less than or equal to type by multiplying both sides by -1. Okay, because here for maximization we need less than or equal to inequality. Okay, now third step, express the problem in standard form by introducing slack variables. That is s1 s2, we have to introduce the slack variable for less than or equal to inequality, that from the beginning itself we have discussed. Now obtain the initial basic solution and display this solution in the simplex table. This is the third step. Now fourth step, test the nature of zj minus cj. We have already discussed all those things in dual problem as well as in big M method and all. It is the revision part only. Now we have, after computing zj minus cj, we have to check one by one case. That is case 1. If all zj minus cj is greater than or equal to 0 or positive, and all xbi, what is meant by xb? Basic feasible solution, okay, which is positive, then converted solution is an optimum feasible solution, we can say. Okay, suppose if all zj minus cj are positive and at least one xb is less than 0, then the converted solution is not optimum basic feasible solution. So in this case we have to go to the next step. And last case, case 3, if any zj minus cj less than 0, then the method fails. Then we have to move to the next step, that is step 5. In this step, we find the leaving variable. That is what we have to find, the leaving variable, which is in the form of what? Which is the basic variable corresponding to the most negative value of xb. Okay, now to find out the variable entering the basis, we compute the ratio between zj minus cj row and the key number. Now the entering variable is the one having the maximum ratio that we have already discussed in big M method. The same method we have to apply here. Now, if there is no such ratio with the negative denominator, then the problem does not have a feasible solution. Okay. Now, next, sixth step, convert the leading element to unity. That is pivot element we need to find. Then we have to convert it into unity by dividing or multiplying with that particular constant. And all other element of key column we have to make 0 with the help of row operation, as we have done in previous cases. Now repeat the steps 4 and 5 until either an optimum basic feasible solution is attained or till an indicator of no feasible solution is obtained. Okay, now after solving problem you'll come to know about the procedure. Now let us move to one by one problem. See here, use dual simplex method to solve the LPP. That is minimize z equal to 2x1 plus x3 subject to the constraints x1 plus x2 minus x3 greater than or equal to 5 and x1 minus 2x2 plus 4x3 greater than or equal to 8 x1 comma x2 comma x3 greater than or equal to 0. Okay, now here minimization given and the constraint also the inequality in the form of greater than or equal to. So they have given in the standard form, but with the help of duality we have to apply the simplex method. Now what is maximization duality? Again the condition same here. Here minimization duality is maximization z dash equal to, here we have to write only these concept along with the slack variable and surplus variable if necessary. Okay, now maximization z dash equal to minus 2x1 minus x3. Here we have to write completely the dual of this, that is maximization and minimization are dual here, plus and minus are dual. Similarly apply the same cases here, minus x1 minus x2 plus x3, right? Here dual of greater than or equal to is less than or equal to, here plus 5, dual is minus 5. Now similarly write the next one, that is minus x1 plus 2x2 minus 4x3 less than or equal to minus 8. Now after writing this step, we have to choose the slack variables S1 and S2 which are positive, such that we have to add that S1 and S2 to both the equation and use equality sign. That is what? Minus x1 minus x2 plus x3 plus s1 equal to minus 5 and minus x1 plus 2x2 minus 4x3 plus s2 equal to minus 8. Now, after writing this, you have to write the table corresponding to the coefficients of this, right? Now, first we have to write CB, then B, basic variable, then XB, basic feasible solution. Now, X1, X2, X3, S1, S2. So, these are the total variables. Now, what is x1, x2 coefficient? Minus 1, here plus 1, then s1 is 1, there is no s2 0, and what is here xb, that is the RHS part, minus 5. Now come to the next one. Here x1 coefficient is minus 1, x2 is 2, then x3 is minus 4, then there is no s1, that is 0, and s2 value here 1, and its RHS part is minus 8, that itself is xb. Okay, now initially what we have to choose here, the first we have to write cj values, that is what here, minus 2x1 plus 0x2, because there is no x2, so cj values are minus 2, then 0, then minus 1, and s1 s2 both are 0, right? Now initially we have to assume here s1 and s2 are what? 0 0. Write that value only 0 0. Base variables are here s1 and s2 only, so the coefficient of s1 and s2 are initially 0 0, we have to assume. Okay, now compute zj. How to compute zj? Multiply this with this, so 0 plus 0. So here each and every term 0, because CB is 0 in the beginning stage. So everything is 0 here. Now after finding Zj, compute Zj minus Cj. That is what? This is 0 minus of minus 2, that we are getting plus 2. Then 0 minus 0, again 0. 1 minus, here 0 minus of minus 1 means plus 1. Then 0 minus 0, again 0, then 0 minus 0, 0. Okay, now after finding this, check most negative number in the row. What is the most negative number? Minus 8. So consider this itself as pivotal row. Then how to find pivot element? How to find? Now here compute Zj minus Cj. Here after finding the most negative number, which one leaves the basis, we have to check here. Minus S2 leaves the basis. So what we have to check here? Most negative number is minus 8 here. Here we are getting the ratio, find the minimum ratio. So here minus 1 by 5, here minus 4 by minus 8, that is half we are getting. So which is the least one, that we have to consider as a pivotal column. After finding pivotal column, here which we get the pivot element in that particular row. So this is the minus 4. So we are getting the pivot element as minus 4, that is least negative number here. Now find Zj minus Cj divided by pivot element. Now what is Zj minus Cj here? 2. 2 by minus 1 for this particular row. 2 by minus 1 compute, it is minus 2. Similarly 0 by 2 it is 0. Similarly 1 by minus 4, that is minus 1 by 4. Again check here which is the negative least number here. Check it. Now we are getting minus 1 by 4 in this particular row, column. Now since here S2 leaves the basis, it is replaced by what now? X3, because pivot element is present here. So S2 replaced by X3 and its value is minus 1. And what we have to do? We have to make this particular element as 1. How to make it 1? R2 implies R2 divided by minus 4. So that this expression will change to what? Here S1, here X3, and instead of 0, X3 value is minus 1, replacing here. And we have to divide R2 by minus 4. So what we are getting? Minus 8 by minus 4 is 2. Minus 1 by minus 4 is 1 by 4. 2 by minus 4 is minus 1 by 2. And this is 1. And this is 0. And this is minus 1 by 4. What is our next step? With the help of this unity, we have to make remaining rows. That particular column should be 0. So what we have to apply the operation? R1 implies R1 minus R2, because here also 1, here also 1. So after applying the row operation, we will get like this. Cj remains same, and here Cb also remains same, B also remains same. Now apply R1 implies R1 minus R2. We will get here minus 7 minus 5 by 4 minus half 0 1 1 by 4, and here this part remains same. Compute Zj. How to compute Zj? 0 into minus 7, that is 0, plus minus 1 into 2, that is minus 2. Similarly compute 0 into first value, minus 1 into minus plus 1 by 4, that is minus 1 by 4. Similarly 0 into minus half, minus 1 into minus half is plus half. Similarly compute everything, this into this plus this into the second value. So you will get Zj value. After finding Zj value, now find out Zj minus Cj, that is what? Minus 1 by 4 plus 2, we are getting 7 by 4. Next 1 by 2 minus 0, that is 1 by 2 only. Minus 1 plus 1, that is 0. Now 0 minus 0, 0. 1 by 4 minus 0, that is 1 by 4. Now again find out least negative number available in which row. This is the least negative number available here. So we have to mark this as a pivotal row and obtain the pivotal column as previous step. Then here simplify Zj minus Cj by pivot element from that particular row. 7 by 4 divided by minus 5 by 4, we are getting minus 7 by 5. Next 1 by 2 by minus 1 by 2, that is minus 1. 0, here we have to take completely as it is. Okay, now here we are getting 1 by 4 divided by 1 by 4, that is 1. Now here what happens? Which one expression changes? Since here pivotal row and pivotal column, here it is available in the first row. So S1 changes. S1 replaced by what now? X2. That is X2 value is 0. So here it will replace by X2 and S1 leaves the basis. Now again we have to repeat the step, that is we have to make this as a unity by multiplying minus 2. So R1 implies minus sorry 2R1. Then what we are getting here? 0. This is X2 and this is, we have to multiply by minus 2 for both all the terms in this particular row. That is minus 2 into minus 7 is 14. Then minus 5 by 4 into minus 2 is 5 by 2. Then minus 2 into minus half is 1. Then similarly 0. This is minus 2 minus half, right? Now after computing this, write the expression R1. It is same. Now with the help of this value, we have to make this element 0. So how to make this element 0? R2 implies R2 plus 1 by 2 R1, because we have to keep the target for this one to make it 0. Now we will get R2 implies R2 plus 1 by 2 R1, and rest all part same. Here we have copied. Now again repeat the process, obtain Zj. Similarly Zj minus Cj. See here, after computing Zj minus Cj, check whether any value is positive, negative or not. If any value negative, then you have to repeat the same process until we should get the positive value. Otherwise you can stop at this stage. So what we can write? Therefore maximization of Z equal to what? What is Z value? Minus 9. And what is x1, x2, x3 value? See, there is no x1, so x1 is 0. And what is x2? Here 14. And what is x3? 9. So x3 equal to 9, x2 equal to 14, and x1 equal to 0. And maximization, because we have converted the dual of minimization, so we are getting maximization value here, that is minus 9. Obviously what is minimization of Z? It's opposite, that is minus 9. We have to convert it into plus 9. So minimization Z equal to 9. So this is the final answer for the given problem. Now next let us discuss problem 2. Solve the following LPP by dual simplex method. That is minimization Z equal to 6x1 plus x2 subject to the constraint what is 2x1 plus x2 greater than or equal to 3 and x1 minus x2 greater than or equal to 0, where x1 x2 are positive. Now first write here maximization Z dash equal to minus 6x1 minus x2, and everything you have to change the sign along with the inequalities. Okay, so this will become what? 2 minus 2x1 minus x2, which is less than or equal to minus 3, and then minus x1 plus x2 less than or equal to 0. Okay, now we have to add the slack variables. What is that? Minus 2x1 minus x2 plus s1 equal to minus 3. Then minus x1 plus x2 plus s2 equal to 0. Now again repeat the same process. First we have to write CB, that is we have to consider the s1 s2 coefficients here, then b, that is s1 s2 base variables, xb. Now we have to write the basic feasible solution here. xb means here RHS part, that's it. Then x1 x2 s1 s2, write the coefficients. Okay, after writing the coefficient, first you have to check what is the most negative value in this, that is minus 3 is the most negative xb here. So this we have to choose as a pivotal row. Then in the column, check what is the, here minus 1 is the negative here. Now we have to choose this as a pivotal column. Now find Zj. How to compute Zj? This into this plus this into this. Since here all the values are 0, so everything we are getting 0. Now compute Zj minus Cj. So what we are getting? 0 minus of minus 6, that is plus 6. Then 1 minus 0 minus of minus 1 is plus 1. Now find Zj minus Cj divided by each element of that particular row. So what we are getting? 6 by minus 2, that is minus 3. 1 by minus 1, that is minus 1. And this is 0. Okay. Now continue this. If you continue, which one we will get next here? Which is the, see, we have to leave the basis of s1, and s1 replaced by what now? x2, and the value 0 replaced by now minus 1. That only we have continued in the next step. Okay, again, which is the least value available here? This is the second row, is the least element, which contains negative minus 3. Now compute zj. Again minus 1 into 3 plus 0, that is minus 3. Again minus 2, then plus 0, then minus 1 plus 0, and so on. Now compute zj minus cj. Again same process. Then zj minus cj divided by this element. So 4 by minus 3 is minus 4 by 3. Again here 1 by 1 is 1. Here 0 by 1 is 0. Now here everyone remember, here 0 by 0 we are considering only 0 only. Okay, because it is not taken in account. You have to be careful with this. Okay, now again, which one leaves the basis now? This s2 leave the basis, and it will replace by now x1. And what is the initial value of x1? We have discussed here in the previous this one. Say x1 is what? Minus 6, right? Now consider that minus 6, right? Now compute zj. Again minus 1 into 1, minus 6 into 1, that is minus 7. Again minus 1 into 0, minus 6 into 1, that is minus 6. Similarly compute for each and every term. Then again zj minus cj. Say dear students, see this cj value I have already taken in the beginning step. Just to go through with that only. So minus 6 plus 6, we are getting here 0, again 0. See here all terms are positive. Stop the iteration. So what is our actual zj value now? That is maximize z, we are getting minus 7. Therefore we can write minimize z, that is equal to plus 7. And what is x1, x2? x1 equal to 1, even x2 equal to 1. So this is the final solution of that problem. Now next let us move to the next one problem. Again, use dual simplex method to solve the LPP. Maximization z equal to minus 3x1 minus 2x2, subject to the constraints x1 plus x2 greater than or equal to 1, x1 plus x2 less than or equal to 7, and x1 plus 2x2 greater than or equal to 10, and x2 less than or equal to 3, where x1, x2 greater than or equal to 0. Dear students, this is very big sum. Purposely I have given this problem because it contains all the inequality greater than or equal to, less than or equal to, and so on. Okay. Now, first write maximization z equal to what? Minus 3x1 minus 2x2 subject to the constraint. Here first we have to write for maximization everything should be less than or equal to symbol. But here it is in the form of greater than or equal to symbol. So how to write? That is minus x1 minus x2 less than or equal to minus 1. And here already given less than or equal to symbol. So x1 plus x2 less than or equal to 7. Write as it is. But here again greater than or equal to symbol is there. So to convert it into standard form, multiply by minus sign and change the inequality. That is what? Minus x1 minus 2x2 less than or equal to minus 10. And here x2 less than or equal to 3 already given. Since there are 4 constraints 1, 2, 3 and 4. So how many slack variables we have to choose? S1, S2, S3, S4. So these are the slack variables which are positive. Okay. So what is maximization of Z? We can write it in the form of minus 3x1 minus 2x2 plus 0s1 plus 0s2 plus 0s3 plus 0s4, because we have to assume the slack variables 0 for this maximization condition.
Now subject to the constraint what? Minus x1 minus x2 plus s1 equal to minus 1. Similarly x1 plus x2 plus s2 equal to 7. Then minus x1 minus 2x2 plus s3 equal to minus 10 and x2 plus s4 equal to 3. So these are the equalities we have converted. So initially we have to assume x1, x2, x3, s0, then s1 equal to minus 1, s2 equal to 7, s3 equal to minus 10, s4 equal to 3 we are getting. Okay, now let us concentrate on the basic first initial table, that is CB. We have to assume s1, s2, s3, s4, that is the coefficient of this we have to assume first, that is 0. Then B means s1, s2, s3, s4 basic variables. Now xb means here what we have to assume, that is basic feasible solution, the RHS part minus 1 7 minus 10 3. Now x1 x2 s1 s2 s3 s4, right, and write its particular coefficients. It is same as previous problems. Now compute zj, and here what are the coefficients? Cj minus 3 minus 2 0 0 0 0. So this is same as the previous sum. After first find zj, then compute zj minus cj. Okay, after computing this, now let us move to the this one. See here, what is maximization of 3 by minus 1 and 2 by minus 2? Here minus 1 and minus 3 we are getting, so maximize element is minus 1. So we have to consider this as the pivotal column. Okay, now let us move to the first iteration. So what happens here? S3 leaves the bases and x2 replace, that is minus 2. And the particular R3 we have to make that particular element as unity. R3 element as unity, that is minus 2 we have to make it as unity. So what we have to do? Divide the R3 expression by minus 2. So what we will get here? It will give this table. Okay, now and here x2 we have replaced instead of s3. Be careful with this, and we are replacing its value as minus 2. Again compute zj, that is what? 0 into minus 1 plus 0 into 7 minus 2 into 5 plus 0 into 3, that is minus 10. Again compute for this. Again here minus 1, here minus 2, here 0, here 0, here plus 1 0 0. Because I rest all 0, we can compute directly here. See that I have given in the next slide. See zj, right? Then compute zj minus cj. Again what is the here maximization of this? See here we have to take drop s4 because this is the least. Here we have to check which is the complete maximization of what is 2 by minus half, that is minus 4, and here rest all we are getting 0 by 0 and all. So this itself is the pivot column. Now this is the, we have to take completely this row as pivotal row, and this we have to skip s4, we have to replace it by x1 and its value is minus 3, we have to take here in the next step, and we have to make this value as a unity by multiplying minus 2. Okay, now this will reduce to the form of this table. Now with the help of this we have to make remaining all element as 0, right? That is r1 implies what? R1 plus 1 by 2 r4. Next r2 implies r2 minus 1 by 2 r4, and r3 implies r3 minus 1 by 2 r4. And write the table once again. Again check here zj expression and zj minus cj, and check whether zj minus cj expressions are positive or not. Here we are getting positive, right? Zj minus cj values are positive. See here all we are getting positive. So since all zj minus cj are greater than or equal to 0 and even xb are also positive, therefore the current solution is optimum basic feasible solution. Therefore the optimum solution is what? Maximization z equal to minus 18. That is we are getting the expression from this here. Z we are getting minus 18, x1 is 4, x2 is 3. Okay, so that only we have to write here. Okay, that only we have written. See, okay, now what we have next, this is the final expression. Now next move to one more problem. Use dual simplex method to solve the following problem, that is minimize z equal to 2x1 plus x2 plus 3x3 subject to the constraint here x1 minus x3 greater than or equal to 0, where x1 x2 x3 are positive, and here one more x1 minus 2x2 minus plus x3 greater than or equal to 4, and 2x1 plus x2 plus x3 less than or equal to 8. So these they have given the inequalities. Again write the same process. First write its canonical form, that is what, maximization z equal to what, minus 2x1, because here they have given particularly use dual simplex. So minus 2x1 minus x2 minus 3x3, right? And here we have to take what, for maximization we have to take less than or equal to, so this expression becomes minus x1 plus 2x2 minus x3 less than or equal to minus 4, and here inequality given in proper way, write as it is, and here we have to change the sign because greater than or equal to symbol is there, minus x1 plus x3 less than or equal to 0. Okay, now here we have to add the slack variables for less than or equal to, that is my plus s1 for the first inequality, and here plus s2 for the next inequality, and for the next inequality we have to add plus s3. Again write cb b xb x1 x2 x3 s1 s2 s3, that is the coefficients you have to write for each and every inequality. For the first one, minus 1 2 minus 1 plus 1, and here there is no s2, so s2 value 0, even s3 value also 0, and here we are getting xb as minus 4. Okay, similarly continue the process for next two inequalities. So we have converted the equality. Now compute zj, again zj minus cj, and check which is the minimum ratio, then zj minus cj by negative element of pivot element, then you will get like this, 2 by minus 1 1 by 2 and minus 3. So what is the most negative integer you have to identify, then which row it appears, you have to change here s1 replaced by x1 and its value is minus 2. Convert everything, again compute the process, that is we have to make that particular element as unity, then make remaining all as 0, right? Because r1 implies, here we are getting minus, say r1 we have to concentrate, and we have to, here we have to make it what r2 implies, r2 minus 2r1, so we have to make this as 0, even this as 0, so it will become what, here this value 0, this value 0, because we are keeping the target for this, already we have explained in the previous step. Apply that, again compute zj, then zj minus cj, see here all values are positive, we have to stop the iteration, therefore the solution is optimal and feasible. And what is x1 x2 x3, you have to write x1 equal to 4, and x2 x3 does not changes here, so x2 also 0, even x3 also 0, but z value is what, minus 8. So maximization is minus 8, so what is its minimization, just change the sign. So this is, see all problems are similar, just go through with one problem properly. Dear students, if you have any doubt you can contact me personally. Thank you.